All right, let's wrap up this section with these laws of logic here. So go back to page 9. So we have two laws of logic. The first is called the law of detachment, and the second one is called law of syllogism. So in the law of detachment, the law of detachment is very, very simplistic. So let me go over this box right here, and then we'll go through some examples. Law of detachment says, if the hypothesis of a true conditional statement is true, then the conclusion is also true. So if you have an if-then statement and the hypothesis is true, well, then the conclusion is also going to be true. So in a way, you can detach the conclusion from the statement because the law of detachment says that's true. And then in law of syllogism, I'll briefly talk about this, but I think sometimes it makes more sense to go through some actual examples. So law of syllogism, you will have two conditionals. The first one says, so let's say generically speaking, if the hypothesis of P, if you have hypothesis P, then you've got conclusion Q. Okay, so like, I'm gonna over here write if P, then Q. And then you have a second statement that says, if hypothesis Q, then conclusion R. So if Q, then R. So if both of these are true, then you can create a third statement. You can conclude a third statement that if hypothesis P, then R. So then you can have this third statement that says if P, then R. So like, here's an example, I guess. If, let's see. Oh boy, if today is Monday, then I will go to school. If I go to school, then I have a good day. So the concluding sentence would be, if today is Monday, then I have a good day. So since I am concluding the same thing that is the hypothesis of the next sentence, it's almost like you can cancel it out. If number one leads to number two, and number two always leads to number three, well then number one will always lead to number three. So in a way you can just, I like to go like this. I like to circle and say if the first hypothesis, then the second conclusion. Okay, so let's do some examples here, and hopefully those will make a little more sense. All right, so go to examples 3 and 4 here. Let's go back to law of detachment. So law of detachment says if you have a true if-then statement, if the hypothesis is true, then the conclusion has to be true. So use the law of detachment to make a valid conclusion in the true statement. If two segments have the same length, then they are congruent. Okay, so hypothesis, conclusion. Hypothesis, conclusion. Okay, you are given this situation. You know that BC equals XY. So you know that two segments have the same length. What can you conclude? I can conclude they are congruent. They are congruent. Okay, so it's almost like you're provided a scenario, an if-then statement. So let's say on down the road you encounter an example of that scenario. What can you conclude? Well, if you're encountering the hypothesis, you can conclude the conclusion. Now, I can't go the other way. Like, let's say I still have this if-then. If two segments have the same length, then they are congruent. I can't necessarily be given the conclusion and conclude the hypothesis. It doesn't work backwards like that. Okay, so it only goes from hypothesis to conclusion. So that's all we can conclude. We're detaching the conclusion, and that is going to be the answer to our scenario here. Okay, Mary goes to the movies every Friday and Saturday night. Okay, today is Friday. So what I'm going to start with, I'm actually going to turn that into an if-then so I can talk hypothesis and conclusion. Okay, Mary goes to the movies every Friday and Saturday night. So actually, your hypothesis is here at the end. So in the form of an if-then, if, let's say, if it's Friday or Saturday, I'll just abbreviate here. If it's Friday, I guess I can say or Saturday. I guess you wouldn't say Friday and Saturday. If it's Friday or Saturday, then Mary goes to the movies. If it's Friday or Saturday, then Mary goes to the movies. So if I turn it into an if-then, I can see the law of detachment maybe a little easier, maybe not. Maybe you didn't have to do that. So here is the scenario. Today is Friday. Well, since Friday matches the part of the hypothesis, I can conclude Mary goes to the movies. Mary goes, or Mary will go to the movies, however you want to word that. Okay, that is the law of detachment. Okay, so sometimes it just feels too basic and it gets more confusing. So if you have a if-then statement and the hypothesis is true, I can detach the conclusion and conclude that to be true as well. All right, so that is law of detachment. Let's take a look at a couple examples on the law of syllogism. All right, if possible, we're going to use the law of syllogism to write a new conditional statement that follows from the pair of true statements. So we are going to, just kind of format-wise, I'm going to be provided two if-then statements. If I can do law of syllogism, my answer is an if-then statement. Versus law of detachment, it's usually just a sentence. It's not an if-then statement. Okay, if Rick takes chemistry this year, then Jesse will be Rick's lab partner. If Jesse is Rick's lab partner, then Rick will get an A in chemistry. So in order for me to do this type of visual, I like to draw this out and kind of abbreviate the topic of P and Q and R. So this is one way that I like to process through this. So if Rick takes chemistry, then Jesse will be his partner. So I might do something like, Rick takes chem, then, so if Rick takes chem, then Jesse is the partner. So I'm just going to say here, then Jesse partner. So if Rick takes chemistry, then that always leads to Jesse being the partner. Okay, so I'm going to do something similar on the next one. If Jesse is the partner, so if Jesse is partner, then Rick will get an A. I'm just going to say here, get A. So here's what I'm looking for. When I see the conclusion in one sentence matching the hypothesis in another, I can almost just cancel them out, okay? Because if Rick taking chemistry always leads to Jesse being his partner, and if Jesse's his partner and he always gets an A, well then we don't need to go through and talk about Jesse being the partner. So here's what I'm able to do. I'm going to go like this. So I can cancel out the conclusion and the same hypothesis, and I have a hypothesis and a new conclusion. So I can use law of syllogism here. If I don't get this repeating hypothesis and conclusion, then I can't use law of syllogism. So I'm going to need to put this into a new if-then statement. So I'll put all the words back in. If Rick takes chemistry this year, then he will get an A. If Rick takes chemistry this year, comma, then he will get an A. Okay? So I'm going to circle this because this is your answer to law of syllogism. What I did in red, it was just a quick way for me to get to my answer easy. Now, you may not have needed to do that. You might be able to tell back from the sentences how to get there. Sometimes those sentences are switched. So even if the second sentence was first and the first sentence was second, I'm still going to get the same answer. So sometimes it's easier to see it this way. Okay, next one. If x squared is greater than 25, then x squared is greater than 20. If x is greater than 5, then x squared is greater than 25. So there's a lot of x's and numbers here, so I'm going to still do the same idea. If x squared greater than 25, and then I'll do my arrow, then x squared greater than 20. That's my first if then. If x greater than 5, then x squared greater than 25. So I'm looking for a hypothesis and conclusion to be the same. And I do have one right here. See how this hypothesis and this conclusion match? Okay, so they can cancel each other out. So here is my new hypothesis leading to my new conclusion. So this is what I meant a second ago, where sometimes the sentences are switched. So I can say then, by law of syllogism, I can say if x is greater than 5, then x squared is greater than 20. If x is greater than 5, then x squared is greater than 20. Okay, so that would be my answer by law of syllogism. Now, if I don't have this repeating beginning and end, then I can't apply law of syllogism. So that does happen at times. All right, I want you to do number 7. Decide if you can do law of syllogism. If you can, write a new if-then. If you can't, then you say you can't apply the law. Okay, I just wrote out an abbreviation, just abbreviated hypothesis and conclusion. If the polygon is regular, then the angles in the interior are congruent. So I have angles are congruent. If the polygon is regular, then the sides are congruent, then sides congruent. So this is an example where I cannot apply law of syllogism. See how the polygon being regular is in the hypothesis twice? It's not like beginning to end. So there is no conclusion here. I'm just going to say here, cannot use law of syllogism. Okay, so that's what it would look like if it's not applicable. So, in a nutshell, one thing to really notice. Law of detachment, your answer is a sentence, not an if-then. Law of syllogism, your answer is an if-then. And so if you kind of look back at what we did on law of detachment, let me find my, here it is. So on law of detachment, here's my sentence, here's my sentence. My conclusion of law of syllogism is an if-then and then an if-then. Okay, so that's one thing to help you decide, can I use it and what should my answer look like? Okay, that wraps up deductive reasoning.